Hi. We got quite a few feedbacks compared to yesterday, and no issues. It'd be better if we start the main class. Okay, main class will be started. Don't worry about it. See, we'll have to do the things properly because there is a way we focus on the sessions, right? So hold on for around maybe today we'll be starting the main classes related to the data sets and data structures. So, but I'll take the feedback. Thank you. And it's clear what is satisfactory, everything goes with more examples. I believe I did give examples, but yes, I will try to increase more examples. Thank you. Okay, thank you. And then it's an empty form. Sorry, this cannot be done uh, due to various reasons. My entire timeline or the calendar is a little clumsy and I have my personal time too. That's why I do not encourage giving the recordings to, ideally speaking, because if you think that you can depend on recording, you will not be, your mind may not focus on the actual content in the session. You'll anyways get the recording, right? So that's why I try to restrict it. But yeah, people want the recordings at any point of time, at any cost. So um, please mute yourself and yeah. Cool. So the gist of it is you will be getting the recordings at least within 24 hours, let's say, in the worst case scenario, okay? If that is causing a serious problem, then just push another feedback form or maybe update in the concerns section in the sheet and we'll be able to take care of it, okay? We'll at least enable someone else the access and everything else. Should this is done. Okay. Okay. Hmm. Use PPT presentations instead of Excel. We do have okay, slow and loud voice. I did not understand the feedback. Are you saying am I that I am going slow and with a loud voice, or are you suggesting I should slow down and I have to increase my voice? But yeah, please push another feedback form with clarity, please.
Amma, there's a map. Map. So.
Please mute yourself, please, everybody. I request you. Okay. So the PPTs will be started within a couple of sessions. We already have a fully equipped PPTs for every topic, as discussed in demo, but I'd like to maintain the sheet as a running notes because we are generating the running notes and I know everybody has a tendency to note down the points before it goes to the next topic so that you will not be missing anything. You will pen it down as a running notes, right? So I'm trying to create that running notes so that you don't have to spend time on generating the running notes on yourself, because when you start writing your running notes, you might miss the next points, right? Because you and I may not be in the same frequency. All right. So that's why we will always be um, making sure that I do the running notes so that at least that will save you some time and that will save you some effort too. But I really need more details about what is slow and loud voice. Do you need to be slowed down, or am I already slow? Something like that, right? So just confirm that and then we should be good. Cool. All right. Disable permissions for people to unmute themselves. Um, I can do that, but it disables the freedom of people. If at all we are facing this issue again, let's say, we can definitely do that, okay? Because I really want people to communicate too. Session was clear. Can you speak it? Okay, a bit louder. Thank you. Sure. If I'm not louder, just let me know. Could you please mute yourself? Okay. Yeah, those were the feedback forms that we have today. Yeah, because it is an intro session, absolutely. We will dig in deeper as we go by. Don't worry about it. Cool. All right. So I see only one answer for monkey patching. I don't know what's going on because we are a hefty crowd here. So all you need to do is find another record and then write an answer, right? And I did not give you too many questions. This is only one question, and you have absolute freedom to do the research on Google, ChatGPT, Gemini, or whatever, right? So please try to put some efforts to fill in the answers. But yes, monkey patching is a concept where we are utilizing the true open source utilities or features of Python, where let's say if you have a software or a framework in Python, for example, pandas, okay? So you can edit the functionality of the core functionality of pandas. You can absolutely try to change the definition. You can absolutely try to change the logic behind it. For example, I'll just open ideally. Oh, it's already there. Okay. So for example, if I say 2 plus 2, right, is equal to 4, right? Or this is how we declare a variable a plus a, 2 is nothing but 4, right? So it is an addition operation, and this plus operator has some implementation behind the scenes. And with monkey patching, or actually, I don't even need monkey patching for this, but I can actually make this plus operator work as a subtraction. I can make this plus operator work as a division or multiplication or any other thing else, right? So that's called as editing the source definition. So this concept of changing the definitions of the magic methods or whatever the attributes that are responsible for these functionalities is called as operator overloading. Okay. Please guys mute yourself. Overloading. Okay. So you can we will anyways cover this in the object-oriented programming, but yeah. So a bit of when you extend this concept and when you change the core logic of the software entirely, right? For example, um, you build a media player using Python, let's say, completely Python, and then you want to change the core functionality, right? Or maybe you sold that software to someone else on based on license, for example, right? That guy took that software and then he has absolute freedom to change the code, the core code, because it's completely open source. All right. So that's the way of changing the source code or extending the source code is called as monkey patching. Okay. So Python will absolutely allow it, and that's the beauty of being an open source. So that's that. And let's first get started with the brief discussion on the integers and the string objects to start with, right? So that at least we'll cover the basics on a high level. So firstly, we were talking about how to declare a variable, right? So this conversation, a variable is something that holds a value, right? Anything that can store a value, hold a value, refer a value, right? So it's just a container, right? So a is equal to 2. 2 is an integer, right? So when you declare this in Python, we discussed yesterday that we don't even have to necessarily declare the data type of it, and Python understands the data type, right? So when I print a, it'll print 2. Okay. So there's something called as whereabouts of an object. Again, it's a completely made up term. If you Google it, you probably may not find about anything on this, but when you get an object in Python, there are few basic ways to understand the attributes, the religion of that variable, the caste of the variable, the properties of the variable, the gender of the variable, or whatever, right? So you can get all the details about any variable or an object using some ways. Okay, you will get yourselves acquainted to that process of exploring a new object in Python. Okay, so you can use something called as type of a for starters. Okay, it'll give you the data type of any object. It's not just for the variables. You can, let's say, import math, for example. Okay, type of math. It says it's a class called module, right? So it'll just tell you what type of object it is, right? So Python understood somehow that it is an integer, and we will discuss how it came to that conclusion that it's an integer. But yeah, for now, as any dynamic programming language works, Python also dynamically recognizes the data type, and type is one of the whereabout which will give away the data type of a given object. Okay, so
I'm
that
sorry to interrupt. Can you please repeat the class module again?
uh yeah, so basically when we are seeing anything new in Python, any object, right? So every object in Python, like I just mentioned, will have a type. It could be the data type, or it could be the object type, right? What it is exactly, something. So if you declare a is equal to 2, this is an integer. It's a kind of a data type that falls into integer category. Likewise, when I am doing the math, it's a module, right? So how do I know it's a module? When I do the type of that object, I'll get what type of object it is. It's a module. Likewise, type is used to give the data type of that particular object.
Got it. Thanks.
So another whereabout of an object is ID. ID of a gives you a number. So basically this number resolves to a storage location called as heap, right? So because Python by default will be storing the objects in heap storage, not stack. Why it is not stack? Because heap is meant for all the dynamic memory allocations. Okay, so we'll talk about it in detail about dynamic and static array, but we already know about 3 different properties of the segregations between the static and dynamic, the 3 different types that we discussed yesterday. So these still stand good, tall and strong, but we will revisit it within a session or two about the static and dynamic. But just understand now that ID will give you the storage location of every object or any object. Cool. So that's that. And there is another thing, another important thing. Just a second. There's something called as dir of a. Okay. So the dir of a will display the functionalities of any given object. This is how you explore any object in Python. Okay. So first thing, the type, to understand what kind of data type we're talking about. Second thing, ID, to understand its location. And we will also get to know about the significance of ID depending on the next steps. But then there's this thing called as dir. When you are exploring the dir of any object, again, not just for basic data type, but also for dir of math mod, whatever we imported, right? Every object in Python, which is a valid object, active object, will be having a dir with a proper output. And I don't know, so this is actually giving me something. If I observe it very closely, it's single quotes and it's a string, right? Something. It has most of the words that are with prefix and postfix of double underscores, right? And then there are words that are not with double underscores. So the only thing that I can observe is there are words that are comma separated and the words are inside the single quotes. And the words are either pre and postfix with double quotes or they aren't, right? Either you have the prefix and postfix as double underscore or that you do not have a prefix or a postfix with double underscore. In case you were wondering if it is double underscore, yes, it is double underscore, right? So that's that. And when you are implementing this dir, what exactly is this doing, right? So you have printed a variable called to. You declared an object, a variable, and you stored a value called to, and the name of the variable you're giving is called as a, right? Guys, please respond in your corresponding groups. That'll be more helpful.
Yes. Yes.
Okay. Cool. So no, not here. I mean, in the groups, they're having questions. So please take care of those responses. Just make sure they know that this is the correct same link we are using. Cool. So the main functionality about dir is whatever an object can do, right, is displayed in here. The entire functionalities of an object by default that is given and available in Python is given by the dir object, which means literally a is an integer again. How do you know? First type of a. And what can a do? What can integer do? For example, there's another interesting question in interviews. So even I asked this question a lot of the times when I was taking the interviews, and the question is very silly. Can we add two numbers in Python? If so, how and why? Right? So you can fill out the answer. Yeah, it is getting recorded. Don't worry about it. Oh, okay. People are not joining because the recording has started. I don't know. Fine. So can we add two numbers in Python? Yes. The answer is absolutely yes. And even a layman who doesn't have experience with any Python or any other programming language can be able to he can guess it, right? That the addition is definitely a possible visibility between the integers. But why? Why? Because you have this guy called as __ add. Okay. So dunder add or magic method add are the two are the very reason for the functionalities that are implemented or implicated for any object. Okay. So I'll be entering the interview questions as we are talking over every concept or every topic, and you're obligated to fill the answers on your own way, by your own research, by your own understanding. And if you're trying to add another answer and if you do not find any record, all you need to do is just add a record and then you'll get the record in this because it is editable. Do not mess up the sheet. We can roll back to any number of versions. The version history is tracked here. Okay. So difference between magic methods / dunders, informally they are called as dunders, versus attributes in Python. Okay. So this is another important interview question. But again, rolling back to your answer to this previous question, can we add two integers and how? When you are adding a plus a, it is working out and it is giving you as 2 + 2, 4, right? But then this a plus a, the backend implementation is nothing but a dot double underscore add double underscore, and then the value. You're again adding a, right? So this is exactly what goes on at the backend. Okay. So it means since you got this magic model available, it is just trying to uh, execute the addition operation, and it's just working out. Okay. So for example, if you have a object, when you do the dir of that object, and it is not working out about the addition, let's say, okay, in that case it means that underscore underscore add underscore underscore is not available for that object, and you cannot do addition. So for example, I'll declare or define something, no idea what it is. When I say the type of D, just says dict. Let's not focus on what it is, but dir of D has a lot of things, but dunderadd is not one of them. It doesn't have dunderadd. So when I do D plus D, it says there is no support for addition operation, right? So you cannot add two dict items. These are called as dictionaries. You cannot do them. You cannot add them because there is no inbuilt dunderadd in the dir of this particular object. Okay, so that's how you'll explore the objects, and for every object you see in Python, you will explore both the magic methods and the attributes, and then you'll then get the functionality about implementing anything, right? Any logic, the core logic. But now, what is the difference between the double underscore objects that are called as dunders or magic methods versus the attributes, right? That is also another important interview question. This attribute is nothing but, again, it is one of the same, right? It has a functionality, that has a functionality, it does something. And dunderadd does something, update attribute should update something, right? So again, what is the core difference? Why are we not having the double underscore for this, and why are we having double underscore for this? Right? Anything, anyways, every attribute you see here, every word you see here has a separate independent functionality, right? So the major deal here is when you declare something as an attribute, you cannot, or you're not obligated to change the source definition of it. You use it as it comes by, right? That is the recommended approach. But when you are using a magic method, any magic method functionality can be prone to operator overloading. Okay. But again, I'll stop it here. It's too advanced for you, at least at this particular current stage. But I want you to do the research on this, and we will discuss about this question in tomorrow's session. Okay. So difference between the magic methods and the attributes. Why do you have those, right? A detailed answer from your research, because learning is always a bidirectional pull. I can always spill over the beans. You will have to be responsible in cultivating them into a plant or a tree, right? So once I find a significant answers for this, you'll be just trying to own your own research on this. Okay. So tomorrow, if you're attending an interview, if people ask this question, we'll make sure you do not miss it because of your research. You will be just owning that answer. Okay. So try to do that, and we'll discuss about this maybe in the next session once I see significant answers. All right. So there's another way about the given objects in Python. They are called as help of A, right? It's got a squeezed text of 3 lines. All right. So it has got a lot of information, description, briefing about all the dunders or attributes. But if you observe it very closely, this is the dir of A, right? It started with abs add and, right? The help object also has some description. It has all these methods, abs add and, right? So it will give you the detailed description of about every object, what it does, right? Because when you do dir of A, you only get the names of the attributes. Add is very English and very generic or basic, that everybody can tell that it is related to something on a addition, right? Is dunders and attributes same thing? Sorry, no. Dunders are different from attributes, right? So the question itself is, what is the difference between dunders versus attributes? So these are called attributes. The ones that does not have double underscore with them are called attributes. And these are called dunders, the ones that are having prefix and postfix of double underscores. They are meant for a similar thing. Every dunder has a functionality, every attribute has a functionality, but not exactly the same. The implementation, they're totally different. They've got the differences, and it's the question that I put here is for you to explore the difference between this and that. Cool. Awesome. Yeah. So you will be having the help as the next attribute. For example, if you're going ahead with to discuss to explore what this does. dir, I don't know, floor, I don't know, float, I have no idea what it is. Index, no idea, right? So if you do not know about anything or any about any attribute here, it's really tough for me to mute everybody. Please mute yourselves as the moment you join. That'll be great, appreciated. So if you do not know about any object, you just do help dot underscore underscore index underscore underscore, right? Trying to focus on this data here called index, and it says it returns the self converted to an integer, right? If self is suitable for use of an index into a list, right? So it says that it will return self in the sense a, okay, whatever the object you're referring there, a dot index, a is the self, okay. So it will return the self, the integer 2, convert it to an integer, right? If the integer is suitable for use of as an index into a list, okay. So if that particular integer is suitable to work as an index into a list. So again, it's too early to comment on this because it involves a list object. We'll come to that later, but let's take another example, right? For example, a simple one, help of a dot abs, okay? Just says abs of self, right? Help of a dot let's say I can just use literally anything here, and yeah, let's use this float, right? It just gives the float version of the self, float of a, right? Let's do that. Float of, right? There's nothing here. It is helping you out. So it says 2.0. The 2 right now is converted to 2.0. So whenever there is a decimal there, that's called as a float. So you're literally converting an integer to float using this operator, right? So you'll be exploring the functionality of these attributes and the magic methods just by this particular conversion technique. But yeah, what you're doing here, you're trying to explore every attribute and every magic method, and just making sure that you got the functionality ready for you. So you're just making sure what the capabilities of each data type is and what each object means. Cool. That's about that. And yeah, as we go by, when we are discussing about every data type and object, we will make sure to discuss about every dunder and every attribute. Not every 800 attribute, and we will discuss about every variable of an object, okay? All the 4 things, okay? Now, we'll have to roll back here to some point. There are 2 different types of data types or the data structures. One is mutable and the other one is immutable, okay? So this is the mapping for every data type or data structure. So you can either have a mutable data type or immutable, right? Same goes with the data structure too. So again, what is the difference between the data type and a data structure? Data type is a basic component. It's not a container. Integer is a data type, right? It cannot hold multiple values. List is a container. A list can have any type of data type, sorry, any kind of data structure or data type, or can have another list also inside a list, right? It's just a container. Those container objects are called as data structures. Just like atom and a molecule. A molecule will have multiple number of atoms. The atom is the basic element of any structure, right? So likewise, the data type is the basic structure of anything that you see. But then when you are having a object that is accommodating multiple data types or data structure, it is called as the data structure. It is just a container box, a box where you can throw multiple items. Okay, cool. So, but again, there are two different types, mutable and immutable. Not just the data types, but even the frameworks or the objects in various technology. For example, Hadoop also is one of the big data platforms that is very famous, and we've got Spark as a market leader, and it was super highlighted compared to the other alternative versions available only because of immutability in RDD, right? So this immutability is very powerful. It will give you added performance with respect to computation or whatever you're doing. So let's just try to understand what is immutable and what is mutable, right? So if you are given an object, okay, if you're given an object and you define an object, you declare an object, and you cannot change the value of that object. I repeat, you declare a variable or an object, you cannot change the value of that object. For this entire session, you will have to use the very same definition for that value. You cannot change the definition of that particular value for that particular object, right? So that is called as immutable. Okay, so it is immune to change. So it will reflect the change. It will not allow the change. So the only way to free up the space is to explicitly free the memory or close the session and then start a new one. Okay. So integers, as we are discussing about the integers, they are immutable. Okay, A is an integer we're talking about, and ID of A is this. Okay, just observe very clearly. Might ask you a question about this within around 10 seconds maybe. So A is 2, ID of A is this. B is 3, ID of B is this. Okay, C is 10, ID of C is this. Okay, E is equal to 2, ID of E is this. These are all the storage locations. Okay. What is the common pattern you're observing here?
Starts with the same sequence.
Okay, and
It is increasing the
Number of digits.
no.
increasing the number of digits.
Do you see anything repeated? The value being
We have
repeated?
the same location.
Yeah, exactly.
ID of E has the same. Yeah.
Yeah. So why do you think A and E is having the same location?
Because both are the number 2.
Okay. So you declared A, and then you got it allocated to ID, and then allocated to 2, and then it is pointing to this ID. Okay. So when you declared B, when you define a value called 3, it is giving you a different ID allocation, which is completely absolutely fine, right? Again, between this and this, right? So if you take out the difference,
32 bits.
yeah, exactly. So it just says it is 32, right? So what it means is the space between this integer and that integer, right? An
4
integer
bytes.
is 32 bits of memory. Yeah, exactly. So that is the size of an integer, a given average integer in Python, okay? But then this IDs, so you declare 2 here, then you're getting it in here, right? So what does this mean? This means that you, no matter what you do, in the entire session, this entire session, before you kill this session, any object that assumes a value 2 will not be declared or occupied, it will not be occupying any space anymore in the heap, but it'll reference the existing heap space, the existing heap space that already has 2 mapped in it. And the mapping is always between the value and the ID. Value and ID, repeat. This is called as object name or a variable. Okay. So the link is between the value and the ID. Tomorrow, if B assumes 2, again the ID will point to the same, right? For example, if I say B is equal to 2, ID of B will again go back to this. All right. So this is called immutability. The immutability is between the value and the reference ID storage in the heap. Okay. So that's about that. And if you are able to change the definition of this, then it is considered as mutable. If you cannot, it is considered as immutable. That's as simple as that. All right. And Python interpreter acts as a calculator, a simple basic calculator. So you can just do this division operation. Sorry, I always play around with 2 because it's my lucky number or whatever. So you can do the multiplications. You can just add, subtract, right? Python also has support by default to the complex numbers. This is called as a complex number. It has a real number and an imaginary number. If you observe it clearly, I gave spaces here in this declaration, and I missed the spaces here in this declaration, but it all round ups to the same. You mention the space, you don't mention the space, it doesn't really matter. Okay, so it doesn't really bother about the syntax in that way. The only syntax Python bothers about is about the indentation, and we will come to that part after we're done discussing with the data types and data structures. Okay, so again, if you want to add complex numbers, if you want to do it with a pen and a paper, it will take some time, but you'll be adding the real terms and the imaginary terms, imaginary entities and real entities in this complex number. And if you want to multiply, again, the little complicated calculation, but you can still do it. And if you want to do it in the program, it is going to be a bunch of sequence of steps. So it's a formulae you're implementing programmatically using Python or whatever language, but in Python, it has a default support. But again, if you're doing this A by B, it's a complex conjugate multiplication in the numerator and the denominator. There's a process. You'll have to find the complex conjugate of this B and then multiply and divide with that. And then you'll have to do that multiply iterations again and again until you find some answer. Okay. But in Python, they have a default support for this. Okay. So at the same time, these complex numbers are also immutable. It also has the same dir, right? So there are definitely some things that are missing when you compare to the dir of an integer, when you compare it to dir of a complex number, right? But yeah, it is what it is. Every object is very simple, very fair and square. If you want to know about anything on the object, you just have to explore the help and dir. That's it. Okay. And about the integers, again, roll back. If you do the type of a, it is called as an integer, right? We now have an integer, and probably we'll definitely have a different ID for now because we never used that value before. So for this declaration of an integer, you can absolutely convert this integer to a string. The thumb rule here is you can convert any data type into a string object. Okay. Just understand that you can definitely convert any object as a string, but you can only convert few string objects to integers or to floats, right? So we'll talk about that later, but anything, any object that you have, any integer can convert as a string. If you're converting as a string, it will be like this, right? So how do you convert? Str of a, something like this, okay? So how do you know that it's a string? Type of str of a will give you the type string. So, or you can just declare another object, b is equal to str of a, okay? Then do the type of b, it'll be a string. Okay, so that's about that. And this is called as typecasting or data type casting, right? You can absolutely convert any data type to any other data type as long as they are compatible with the conversions. That's that. And when it comes to Python 2 and 3, there are differences, right? Um, so int divided by int is an int in Python 2.7. Okay, int divided by int is a float in 3.x. All right. So when you divide two integers, it's always float. Okay. So for example, 23 by 3 will give you 7.66, right? So you will, if you do the same operation in 2.7, it'll just give you 7, which is wrong, right? If you do the same operation in 2.7 with float of 23 by 3, like this, then you will get this in 2.7 also. Okay. So that's about that. Just know about the difference between 2.x and 3.x because it is also a very commonly asked interview questions. Okay, we'll cover all the other points as we go by incrementally for every object. So what is the difference between float versus, yeah, that's what exactly what I'm telling, right? So float of an integer can be a float, right? But what exactly is going on when you're doing this float of this? This is happening. Both are same. The implementation of this at the back end is this. How do you know it? How do I know and how are you sure that I'm not bluffing? Right? So this is the help of it. It will give you the description and it will just return the float of that particular cell. Right? Both are same. Every operation, in fact, whatever you're implementing for any object will be associated with one or a combination of dunders. Okay. So this is a dunder and this is an implementation of the dunder. Cool. So we'll come back here and then we will just discuss about all the other things. Please feel free to fill up all the other details as you do the research, right? So we can always change the answers, we can always append it. But yeah, it's actually a kind of a two-way thing. I do it, you do it, we together pull it off, okay? So that's about that. And yeah. We are still talking about the integers. The division is the difference between 2.x and then 3.x. And if you want to swap two numbers, but before that, hash is used for comments. Okay. The moment you see a hash prefix in the script, your interpreter will ignore it. It'll think that it is for developers understanding, then it'll just skip that particular line. It will not consider or even bother about it. Okay. So that's about the comments, and you have two different types of comments here. One is this hash comment and the other one is triple quotes. We'll talk about it a little later when we're talking about the string data structures, string data type. So just consider that in a program, you need an understanding to the program, right? You don't expect everybody to go through a 500 lines of code, right? For example, if you open a very sample code, you don't expect people to know the functionality of all this. What does this entire object is doing, right? And these objects cannot be named or declared according to the functionality. It can be anything, right? Until you backtrack the definition of this particular object. For example, I want to know about this, right? These connections is this. And what is this? Is getting the connector details for all these attributes, right? You want to debug this as a layman developer, right? As a person who did not write this script. So in order to avoid that particular debugging, we will have the comments, okay? Before we start any declaration, it's always good to have a comment section, right? So when you comment, it's plain English and you will know what exactly to comment on, right? You will say, you will explain or describe about every object that you're using, right? So for example, if you see this, it has every right to return only this particular thing, right? And this, right? If you see this example usage with a hash, right? Literally, if you copy the entire code, right? So if you copy this entire code, something is wrong here. Yeah, it's a copy paste issue, but if you copy the code entirely like this, and then execute it here, it will still work it out, right? But then if you come here and then you remove this entire thing, right? And then execute, it will still work out. The same output, right? If you remove this, execute, it will still work, right? So the significance of comments is this. You just, this is for readability for users to understand what this function is doing about and what argument it has got, and the integer for data type, whatever it is expecting, and what it returns, right? It's about the basic description about the function. That's it. Okay. So can you also please touch on which type of comment is widely used? Yeah, multi-line we use triple quotes and single line we use hash, but yes, I will touch base with hash versus triple quote in string objects. That'll be more clear, not at the integers, okay? But we can use this and that. If you have too many comments, you will be using multi-line comment, and you'll be using multi-line comment for block quotes. It's called as block quotes like this. For every function, you will be describing the description, and this is what you see under at the back end of underscore underscore doc. This object is responsible to map with this functionality, and you use the doc, you'll get this description returned. Okay, that is used for with triple quotes. Cool. Now, another important topic here is swap to integers. Okay, so there are multiple algorithms that are present in the world right now that are related to swapping the numbers. Okay. So, for example, if you want to swap two numbers, how would you do that, right? A is 200, B is equal to 23, for example, right? If B has to assume a value of 200 programmatically, right? You cannot just, if you do B is equal to A, B is 200 now, it's good. A is also 200, but you lost the value of the initial B to swap, right? So that doesn't work like that. Again, I'll declare these two, B is equal to 23, right? So when you swap, B should assume 200 and A should assume 23. And they cannot remember their previous memories. They're not humans, right? What we will do here, one technique we use is, any thoughts?
Use a third variable.
Yep.
A comma B equals to B comma A.
How does that work in any programming language?
I mean, like if you are not taking any temporary variable, then
Yeah, exactly. So we'll discuss about that also. So the whole point of discussing is about A comma B is equal to B comma A. That works only in Python or any other dynamic programming language. So, but then without that, we'll have to take additional variable, and we can also do it without the additional variable. Okay, I'll talk about that also. So maybe you can do a research, and I can also show you an algorithm that works without a third variable. There's a multiplication division thing that we'll get, and then we'll construct the difference of this, and then we will just interchange the values. I'll talk about that, but for starters, in a very simpler way, you declare a third variable, and then you assign the value of it to A, one of the variables value to this third variable, right? Now, A is this, B is this, E is this, okay? Now, if you declare A is equal to B, you know that A will lose its original value, right? But that value is still there with E. So it's okay to lose it, right? Now, A is this, B is this, E is this. Now, we just have to say B is equal to E, right? So now, A is this, B is this. It's swapped or interchanged. A very easy logic. Again, in order to implement this, I'll redeclare these values. A is 200, B is equal to 23. Then what did I do? What did I do? E is equal to A. Okay, that was the first step. And then A is equal to B, second step. And then B is equal to E, third step. Now A is 23, B is 200. Swapping is done, right? So you have to declare a third variable and define another memory, and then implement this swapping. And there are other algorithms where you can just swap the elements. You see this? You will get an idea about the algorithm and detailed steps about swapping without the usage of third variable. And the reason why this is the variable, okay? The reason why people have to do this, right? Why do even people have to do this, right? Because it's a very easy thing. You don't have to involve any calculations or mathematics. All you need is just to involve a third variable and you are done with it. And we just saw it, right? Why we do it? Because we need optimization at a bigger scale. If it is a very huge amount of data in real time, every IO matters for us, right? But then if you are talking about Python or any other dynamic programming language, Python, you just simply do A comma B is equal to B comma A, and A is this, B is this. Again, A comma B is equal to B comma A is this, and B is this, right? It's swapped. So that's another thing with dynamic programming languages. They allow swapping in one line, because you're literally just mapping the reference IDs, the value and the ID. The value and the ID itself is what it matters, and this is just a reference link. Okay, so when you say a comma b is equal to a comma a, that also works. All right. So it just assumes a value declaration and it will just override, right? So just think of it as a one-line swapping, and it is compatible with dynamic programming languages. Cool. So we today have explored new things about whereabouts of any object. Given that use case, you can explore or know in detail about any object. So I think we are already at the tip of the hour. I'll be closing the recording for now, and I'll open the session for the questions.